Hey, I'd like to go over the structured cabling assessment with you so that everybody can get 100% on this. So hopefully you've had a chance to install some structured cabling in the back of the lab. And I'd just like to go over the test real quick so you understand the answer. So room A, which is this, is typically called a wiring room. Some people call it a cabling closet. That's where all your cabling gets located. So like on a 3-story building, you're going to probably have a wiring room on each closet. On a big, wide building like KCTC, you're going to have to think about where you'd like to put your cabling closets in a place that makes sense so you don't wind up with cable runs that are too long. Backbone wiring, that's the wiring that goes from floor to floor, or usually you're going to cable switches to other switches with your backbone cabling. So backbone, it's also referred to as vertical cabling. It's usually fiber optic. I didn't write that answer on there. So in a modern network, your backbone cabling is typically going to be fiber optic cabling. You have a rack right here. Your networking equipment is put in racks. In our class, switches, routers, servers, punch down blocks going to be in a rack. You could have an uninterruptible power supply, a tape backup, just about any piece of equipment you can buy nowadays can be rack mountable. Moving on down, this wiring that goes from your wiring closet so it goes from your punch down block out into the work area. That's called horizontal cabling or Cat5e or UTP cabling. So that's what you ran in your class, and that's the wiring that you labeled. The little box itself out here, slang is a drop, and what that really is, if you wanted to buy one, what we did was 2-port surface mount modular boxes. That's how you would buy it. Moving on, G, patch cable, that's from your computer itself. So from your computer to the drop, that's a patch cable, and it's typically Cat5e cable. OSI model, the cabling is always layer 1, and things that emit EMI or cause problems with electromagnetic interference, industrial machinery, like big industrial machinery, or commonly in an office environment, fluorescent lighting. On the back side here, some examples of things you do to eliminate fiber optic cabling or eliminate EMI is run fiber optics. It's a light signal, it's immune. Completely impervious to any sort of EMI. That's the best way to do it. If you can't run fiber, then another way to do it is just avoid it altogether, like reroute your wiring as to avoid the source of EMI, or you can run shielded twisted pair cabling. That's what the S means, shielded. A UTP is unshielded twisted pair. That's what we ran in our room. Most of the times you're going to run unshielded twisted pair cabling. It's a lot less expensive. When you're running your cabling, the question here says how much cable do you want to untwist? The answer is minimal. So you want minimal untwisted wire so you don't have crosstalk inside your cabling. If you have too much untwisted wire, then you have crosstalk. Another name for a patch cable is Cat5e UTP cabling. The maximum distance is 100 meters. For your cable run, it can't be more than 100 meters. What people sometimes forget about is the patch cable on both sides. So into your work area, you have a patch cable, and then a drop, and then you have your horizontal cabling that goes to a punch down block, and then from the punch down block to a switch. Typically that cable segment is supposed to be 90 meters, and your patch cables on either side, that allows for 10 meters total. So then your patch cable shouldn't be any longer than about 5 meters, which is about 15 feet. So that's typically the standard for installing cabling in a business. To make a crossover cable, you just wire one end to 568A and one end is a 568B. What you do is you cross your orange pair and your green pair up. So what that looks like when you run your cabling is you have your 8 pairs. What that looks like is normally 1 goes to 1, 2 goes to 2, 3 goes to 3. But what you do is you intentionally take 1 down to 3 like that, and 2 and 6 switch up. And the rest of them are straight through. So you take pair 1 and go to 3, and you take pair 2 and go to 6. That's what you do for a crossover cable. Modern computers automatically will cross over the signal for you, so a straight through cable will happen to work for you. But if you need to make a crossover cable, that's what you have to do. Attenuation, that's signal loss over a distance. So at 100 meters, the signal is weak, and the standard says that at that point you should do something to fix it, like install another switch, run fiber optic cabling, install a repeater. So signal loss over distance. Crosstalk, that's electromagnetic interference from inside the cable, so that's the cable pairs itself interfering with each other, and EMI is electromagnetic interference. You would use a crossover cable to set up similar equipment. So if you had to connect a switch to a switch, a PC to a PC, or a router to a router, that's when you use a crossover cable. And then the bottom of this test starting right here, I just want you to bring me an example of a crossover cable or a straight through cable that you made, that you crimped. And then this part here is the cabling that you installed on your for your network. So that's it for the structured cabling assessment.